In this tutorial, we're going to build a system that displays sprites for our input bindings using a dynamic system based on the action name. This system will support keyboard and gamepad bindings. This is similar to a system I use in my game Don't Drown, and today we'll be building it one step at a time. The final project files can be found on GitHub, link in the description below. This tutorial builds on top of Display Button Prompts as Sprites using Text Mesh Pro by Christina Creates Games. So, you should follow that before you start to follow this. At a high level, here's the steps we'll take. Use a scriptable object to interact with our input class. Make our scriptable object return input bindings based on the name of an action. Create a function that can replace action names with sprite tags. Update the complete text with button prompt sprite to support the active device. Make set text to text box update when the active device changes. Add additional actions and set up a Rebinding UI. Update our text components when the input binding changes. First, we're going to create a scriptable object called InputManager. This object will ensure we always have a single instance of our player input. We'll create a method that returns a reference to the player input so we can use it in other scripts. In our setText-to-TextBox script, we're going to reference the input manager and use it to get the player input, instead of creating one in the awake function. Once our scripts finish compiling, we'll assign a reference to the input manager. Since we don't have one yet, let's create it next to the other scriptable object. Then, we'll assign the reference and ensure that everything still works. Next, we're going to refactor the device type enumeration and make it publicly accessible since we'll use it in multiple locations. In our input manager, we're going to create a method that returns an input binding based on an action name and a device type. We're going to use the findAction method to get the input action reference for our action and then get an input binding based on an index, similar to what we did in setText-to-TextBox. In setText-to-TextBox, we're going to replace the way we get an input binding. To show that these are equivalent, I'm going to make a reference to the old way of getting the input binding. Then, we'll call our getBinding method with our actions name and use it as the input binding we pass to read and replace binding instead. Once our scripts compile, we'll double check our action name to ensure we didn't make a typo. If everything looks correct, we'll press play and make sure things still work. Next, we're going to create a method that will create a sprite tag for us based on an action name. We're going to use our getBinding method we just wrote. Our method will take in an action name, device type, a reference to the input manager, and a list of TMP sprite assets. The setText-to-TextBox script already looks up an input binding based on an action, so we'll copy that code to our new method. We'll also replace the lookup of the TMP sprite asset with the way the setText-to-TextBox mono behavior did it. We already know how to get the correct sprite name, so we'll copy that code from the read and replace binding method. Note, for this version, I'm using the effective path on the action, which removes some of the text we had to clean up earlier. In order to help us debug, we'll print out the action and effective path when we find an input binding. Then, we're just going to return the sprite tag, which is computed the same way we did it in read and replace binding. In our set text to text box script, we'll append the sprite tag to our text just to ensure things work. Remember to pass in the device type, input manager, and list of TMP sprite assets. Once our scripts compile, we'll test our code and double check that we get a second sprite on our text UI element. You should see an additional sprite tag on the Text Mesh Pro component. The sprite tag should also work correctly when we switch the device type. Next, we'll build a system that can find the names of actions between braces and replace them with the sprite tag. We'll be using regular expressions for this. If you don't know what those are, there's a link to a tutorial in the description. To help create our regex, we'll use the Regex 101 website. We'll first write a test string with multiple actions and then work on a regular expression that lets us capture the names. We'll use an ungreedy regular expression so we can capture multiple instances in one line. Since we are working with C#, we'll switch to the flavor to .NET and use the code generator to get a sample for how to interact with regex in C#. Next, we'll add a new method to the complete text with button prompt sprite script, which will take a text and replace all the actions with sprite tags. We'll call this replace bindings. First, let's make constants for our pattern in a regular expression, since these won't change. Then, we're going to use the regex matches method to get a match collection. For each match, we're going to retrieve the first capture of both the first and second groups. Our first group contains the text with braces. Our second group contains the text without it. We'll debug log it just so we can see what the regex captured. We'll use getSpriteTag to get the tag based on the inner part, which is the action name. Since that method requires a device type, input manager, and list of TMP sprite assets as arguments, we'll make our current method also require those. Next, we need to replace the text. So we'll make a reference to our text with actions, and we'll use this as the replace the text. For each match, we'll replace the text with braces with our sprite tag text. As the last step, we'll return the replaced text. Since we copied the input from the generated code, we just have to swap that to text with actions. In set text to text box, we'll replace our message so that it uses our new pattern-based approach. Note that we should be using braces instead of square brackets, which I will later realize in the video. We'll also change the text of the text box to use our new replace bindings method instead. Double check that our message uses braces instead of square brackets. Once everything compiles, we'll test our new system. At first, it won't seem like it worked. This is because we overwrite the message from the inspector. So we need to overwrite the message in set text to text box instead. Once we change that, our system should now work and support multiple actions. Next, we're going to make our input manager keep track of the active device between keyboard and gamepad. We'll set our initial reference to keyboard. In order to track inputs, we need to enable an action map. We'll enable our player action map in the onEnable method. We're going to listen to the onActionChange callback, so we'll create a method that takes an object and an input action change parameter. I'm calling mine trackActions. In this method, we care if the change event is an action performed event. If so, we'll determine what device type the action just occurred on. We'll check if the device type is a keyboard or gamepad device and update our active device field. You can further check based on brand of the gamepad if you have sprite sheets per brand. I'll just lock the controller brand at the moment. In our onEnable method, we'll register our method to the action on the input system. As a good practice, we'll also unregister on the onDisable method to avoid leaving a callback on a null object. Our complete text with button prompt sprite script is going to be updated to support replacing text based on the active binding. This will use the replaceBindings method we wrote earlier and just retrieve the active device from the input manager. We'll call this one replaceActiveBindings. Since we haven't implemented a method to get the active device, we'll update our input manager now. Don't forget to return the string when implementing this new method. We'll also update our setText-to-TextBox script to now use replaceActiveBindings instead. Once our scripts compile, we'll hit play. This should result in the text ignoring the device type and always using the active device when we call setText. In the next section, we'll make this change automatic. Since the input manager detects when the device changes, it'll make an action available to other scripts so they can be notified of a change. We'll call this Active Device Change Event. Our TrackActions method is going to change to detect when the device changes. To do this, we'll make a new device reference and assign the device type based on the change event we get. If the current active device is not the same as the new device, we'll fire an event. We're using the null conditional operator to fire an event only if we have one or more listeners. We'll also update the active device to be the new device. Back in our setText-to-TextBox script, we'll now register the script to be a listener to the new event. When we receive the event, we'll simply call setText. As a good practice, we'll also stop listening when the script is destroyed. We don't have to change anything else since we already use replaceActiveBindings. Once our scripts compile and we enter play mode, the text will auto-update whenever we press a valid action on the keyboard or gamepad. Now that we can do this with one action, we're going to create additional input actions to further test our system. Create two new actions, kick and jump. Ensure they both have a keyboard and controller binding. Next, we're going to make a basic UI that will serve as a rebinding controls UI. This UI will be very bare bones and not pretty at all. Start by creating a panel which will hold our controls. Mess around with the layout a bit and ensure you keep the text prompt somewhere visible. Once you're happy with how it looks, create a child element which will serve as a template for a row. Each row will have a label and a button. I'll be using horizontal and vertical layouts just to space things out nicely. In each row, add a TextMesh Pro component which will serve as a label. Also add a TextMesh Pro button which will display our current binding and later serve as the rebind action. Once you have your first row, add a setText-to-TextBox component to the TextMesh Pro component of the button. This will be used to display the sprite. Its message will simply be the name of the action. Duplicate your row a few more times until you have 3 rows, since we have 3 actions. Update your labels and set text to text box based on each action. Remember to use the correct name. Remember to assign the input manager and list of TMP sprite asset references on each of your set text to text box components. If you have sprites named correctly and your sprite sheet contains sprites for each binding you've assigned, you should see icons for all your actions once you hit play. Mine were a bit small, so I changed all my buttons to auto size just so the sprite would scale up automatically. If you press the gamepad, your buttons should also swap correctly. If you named your sprites incorrectly or you're missing sprites, you'll get a yellow square with a question mark. In my case, I forgot to name a sprite Button Quest. As the final test, we'll update our original UI text to contain all our actions. You'll notice this didn't work and we have a null reference exception. We'll fix this in the next section. In this section, we'll fix our regex to support multiple actions in one line. Here's why this breaks. Using the debugger, I'm able to see that the action name didn't split into multiple names correctly. So there's a problem with our regex. If we go back to Regex 101 and use our .NET flavor, you'll notice that it is capturing only 2 matches. This is caused by our regex being greedy, which tries to match anything, including the first closing brace, as part of the first match. We wanted to stop at the first brace, so we'll use the lazy version to match as few characters as possible per pattern. Back in our complete text with button prompt sprite class, we need to change our regex to include the question mark to make it lazy. Once our script compiles again, our bug should be fixed. Next, we're going to implement the ability to rebind our inputs. This is not an InputSystem tutorial, so I recommend you watch other videos after this to fully understand what we'll do. I personally recommend watching CodeMonkey's tutorial and also referencing the Warriors project by Unity. First, we'll create a panel that will only be displayed while we're waiting on the new binding. You can make this panel as stylized as you like. Next, we'll create a new script that will have a rebind logic. I'll call mine rebind input button. This is not a button, but it will go on a button. It will need a reference to the input manager and a reference to the panel we just made. We'll also make a reference to the rebinding operation script in the input action rebinding extensions package. Next, we'll create a start interactive rebind method. This will be called when a user clicks on the button. This method will use the input manager and retrieve an input action reference based on a name. Let's assume the input manager has a getAction method. We'll also need a way to set the action name in the inspector, so we'll make that a serialized field. In our input manager, we'll now make this new method which will only take an action name. Our getBinding method already did this, so we'll copy that line and then change the getBinding method to call getAction. Now, back in our rebind input button script, we'll assign a reference to the action. With this action, we'll call perform interactive rebind and assign that to our rebinding operation reference. Now, we'll configure that operation to exclude the gamepad start button and also cancel rebinding. We'll also configure it to cancel when a user presses escape. There's a known bug in Unity that the E key also cancels the operation if we configured it via with canceling through. Instead, we'll check the operation ourselves and decide if it is a true escape or not. We'll wait for 1/10 of a second once a match occurs. Then, we'll set cancel and completed callbacks to call methods we'll write in a bit. Our implementation of rebind canceled only needs to do a few things. First, we'll dispose the rebinding operation. Then, we'll hide the rebinding panel. Don't forget to show the panel when you start rebinding, which I missed and later realized. Next, our rebind complete function will do similar things. It will dispose of the operation and set the panel to hidden. It will also be responsible for reloading the text at the moment. We'll need a reference to the setText to textbox script so we can call its setText method. Since that method isn't public, we'll make it public now. Once your scripts compile, we'll add the new script to the first button. Assign the references to the input manager, the rebind in progress panel, set the action name, and the setText to textbox script. Also assign the button's onClick function so that it calls Start Interactive Rebind. Now, when we try our button, we'll get an error because we haven't disabled the action map. We'll update our Start Interactive Rebinding method to call the input manager and disable the player action map. Don't forget to also activate your Rebinding in Progress panel, or else you won't know when the rebinding is happening. Since the disable player method doesn't exist on the input manager, we'll go create it. Its implementation should disable the player action map. We'll also add a method that enables it so the rebind button can turn things back on. Update rebind cancelled and rebind complete to call enable player after disposing of the operation. As the last step, don't forget to start the operation. You should be able to rebind inputs now and see the button update the image. Our current implementation allows us to rebind keyboard keys to the gamepad controller, which is why we get the missing sprite image. You can see the system tries to retrieve the sprite for our keyword W in the console, but it will use the gamepad sprite sheet since that's the active control. We'll fix this in the next section. Our current operation assigns the new binding to both the keyboard and gamepad controller schemes. We're going to use a binding group filter to only change the input binding for the current device. We'll assign a string based on our binding groups in the active device. By default, we'll start with the keyboard group and change it if the active device is the gamepad. We'll then use with binding group on our operation, based on the string. Once our script compiles, we'll test the behavior. Now, our code only assigns an overridden binding based on the active device type. You can further limit this by using with controls excluding if you'd like. Our current implementation still doesn't update the text on the bottom, so we'll fix that in the next section. Similar to our device change event, we'll fire another event when the bindings change. In our input manager, we'll declare a new event called bindings changed event. Scripts will register themselves to it if they need to update when a binding changes. We'll use our track actions method and add another if statement. This time, we care about an input action change event where bound controls changed. If we detect the change, we'll fire our own bindings changed event. Next, we'll update setText to textbox to perform the same behavior it does on the active device change event. Now that this is set up, we no longer need to call setText externally, so we'll make it private. We'll update rebind input button to not call setText as well. Once our scripts compile, we'll hit run and test our system. There you have it, a system that auto-updates itself when the control scheme or the controls change. Here is what the system looks like in my game. The core functionality is the same as what we just built. Most UI elements auto-update themselves based on the controller or keyboard becoming active or the input bindings changing. I hope you found use in this tutorial. If you have questions from this video or my devlog, feel free to comment below. If you want to help me out, Please add Don't Drown to your wishlist.